Okay, this is going to be the first segment of a series of videos in regards to Introduction to Java. This is going to be the first level playlist where I go over some of the more fundamental aspects of Java. So let's get started. So, what exactly am I going to cover? In this particular video, I'm going to be covering the core concepts of Java, some of the algorithmic thinking related to Java, and some of the programming technicalities that you want to face before you take on this programming class. So, what is Java? Java is an object-oriented programming language. And I'm pretty sure if you had Java before or are taking it now, you're probably hearing this everywhere and you might understand it, maybe you might not. You won't know until you've gotten a bit deeper into the actual programming, until you get a full understanding of what it is. But let me give you a shallow definition to say for now. So, when we think about Java, we want to think about a tree. Java is a hierarchy. Everything stems from an object. If you have an apple, that's an object. If you have a pear, that's an object. But what we want to understand right now is that if I have three apples and one of the apples is a star-shaped apple, I have a second apple that's a square-shaped apple, and I have a third apple which is a circle-shaped apple. Those three apples are what you call type apple. So no matter what you say, those three are going to be apples. They're just different shapes. That's a type. Apple is a type. And each of those apples are what we call instances. The star-shaped apple is an instance of apple, and a square-shaped apple is an instance of apple. So, apple is an object. So, we could say that the star-shaped apple is an object as well. Now, think of it as a tree and just look at the slide picture. You don't have to understand any of this. Just know that it branches. There's a lot of branching in Java. This is something important to understand before you start manipulating and start acting with objects. But let's get on to some of the algorithmic thinking first. Say you want to eat a potato, but you only eat your potatoes peeled and boiled, a very particular trait. Or maybe not, who knows. So you begin with a potato peeler, a pan full of water, and a stove. That's going to be your given. You're going to have that before you do anything. What's your algorithm for eating this potato going to be? Yes, I'm gonna guess you did this. Your input was the potato. Your input was also the potato peeler, the pan and water, and the stove. Your output was a boiled potato. If you did your algorithm correctly, which is just the process for what you would have done, is you probably would have done something like peeled the potato and then boiled the potato. Doesn't matter if you boiled the potato and then peeled it. Regardless, you're going to have a boiled potato that's peeled, right? So as long as you follow the process, regardless of how you did it, if you did it correctly enough to get the right output, you did it right. But what was the point of this, right? That's probably what you're asking. You want to understand that in this particular situation, you are the implementer of an algorithm. You took in an input, which was the things I talked about earlier, the potato peeler, and the other things, and you ran an algorithm, which was boiling and peeling the potato. And then you threw out an output. That sounds something like what you want the computer to do. So, programming is basically about giving the computer an input with an algorithm to achieve a desired output. You give the computer something to do, and it'll do it for you. That's what you want to do. But you have to tell it what to do, because the computer is not a smart thing. It doesn't talk. It doesn't talk to you. It doesn't think. You tell it what to do. So what's needed before you program? What's needed before you tackle Java? A lot of people say the amount of math you need is Algebra 1, but I would actually suggest geometry, which, if I'm correct, is one level above Algebra 1. If not the other way around, and doesn't matter, you need both of those. Now, why do you need geometry? I would say the proof techniques and induction, deduction, those things that you learn in geometry are very important to be the base of some of the more logical aspects of your code. You want to have correct, accurate, concise, and very understandable code. It's important to understand that style and understandability of code is important. And this includes logic behind what you're doing and being able to explain how you got there. This is what you cover in geometry, and the variables are clearly Algebra 1, right? But programming is not all about programming and algorithmic implementation. There are definitions and terminology tied in with programming, and you want to understand these definitions and terms. Now, when you first think about programming, you would think, oh, let's get into it and start right away. But if you don't understand these terms, you're going to start struggling. But it is true, the best way to learn how to program is through experience. So, who knows, maybe you'll learn along the way. The resources I'm going to be using in this list of videos is Dr. Java and the other two links I have there. The reason I call those two the other two links is because I'm not going to be explaining them until later on. And yes, they are very important links. The first one, though, is something you should check out first. Dr. Java is the development environment we're going to be using, and the recommended one, I would say. You could be using Eclipse when you're doing this. It wouldn't matter either way, but I would recommend Dr. Java. It's simpler to use and has a very clean interface. Particularly for me, I would say Eclipse is a bit confusing at first. So if you're a beginner, I would suggest going with Dr. Java. It's easy to understand, and you could just go on their website to download. There's a great description there how to download, and yes, the other two will be explained in the coming videos, so you don't have to understand what it does or what it is. Just go check it out for now. And